Hello, hello everyone. In this initiative to build examples of how to interact or use artificial intelligence agents in the help of our daily tasks, I'm gonna show a new initiative. So in this case, we have prepared, or I have prepared a new project or more complex example on how to interact with the artificial intelligence agents. We pretend to build an interactive or intend to build an interactive periodic table with the help of artificial intelligence agents. So this is a complex task, could be considered as a whole project itself, and artificial intelligence can provide everything we need to fulfill this aim, this objective. Initially, to build the interactive periodic table of elements with the help of artificial intelligence agents, we need to get the raw data. The raw data in the periodic table of elements is you have seen it many times, the periodic table of elements in chemistry subjects, and we need to get the raw data in order to load into some kind uh, of application to store them. We have chosen a database, SQL database for that. So all the raw data contained in the periodic table will be loaded into a database where you can ask using standard SQL commands on the information related to the elements of the periodic table. Many information will be loaded there, some parameters will be stored in the database. So finally, we will make it available graphically in some way. So you can select the element and see all its parameters. And you can interact with the periodic table using the mouse buttons and choose another element and the application will show the contents of the parameters in the periodic table. So first of all, we need to choose an agent. There are many agents available nowadays. You can choose Copilot from Microsoft, ChatGPT from Tesla Group, Gemini from Google, and for this example, I have chosen Gemini. So in the more specific way you ask the question to the artificial intelligence agent, you will get the better results. So in this case, we will ask the question to Gemini in order to create the first part of this project or this example. Well, I asked the Gemini how we can show periodic table in a CSV comma separated values file for the periodic table data in order to be loaded easily in an SQL database. As you can see, the Gemini replies with the periodic data table in CSV format, so in a file. And in this file there are many columns: atomic number, symbol, element, atomic mass, period, group, phase, type, atomic radius in picometers, electronegativity, etc., etc. All this data will be stored in a database loaded from this CSV file. So what we need to do now is choose and install a database distribution in our operating system. There are many distributions available. You can choose MySQL, PostgreSQL, MariaDB, many others. If in this case we will choose, well, I have chosen MySQL for simplicity. Then we have to configure user and grant him or grant her privileges. So grant all privileges on the database to the user we choose in order to allow us to later on load initially create the database structure and schema and then load the CSV values into the database. So how do you install the database in an Ubuntu distribution? Using apt install MySQL, it will show MySQL Server 8.0 is available. So you choose MySQL Server 8.0 with sudo to become root super user, root user. So it doesn't show any conflict and the database will be installed on the system. Once you have installed the database, you need to create a database space or a schema. In this case, we have created a database schema called chemistry, which is just a name because we use the periodic table of elements, so it makes sense to me at least. And there you connect to the database using MySQL command, minus user Fernando is my name, minus password, and there you put the database. It's available in MySQL 8.0. You there put the database and directly go into that database. If you don't want to, add the database on this first or initial command, you can navigate into it as usually is done in MySQL. You go into MySQL with minus user and minus password. There you can show databases. You see chemistry is already there, and you say use this database, and you go inside. Once we have done all these previous tasks, we ask the artificial intelligence to help us generate the structure or the schema of the table. We only need one table initially, so it's enough with one table. As you see, when you consult the table on paper, it's only one table. So here is the same, only one table. And we ask the artificial intelligence, Gemini in this case, to generate the SQL needed to create the table in the database. You can see it generates the SQL, create table, periodic table. You can add if not exist, but it's not needed that we know if after the installation the database space is empty. So primary key will be the atomic number as it's in the periodic table of elements. The atomic number will define the element as an integer. It is the primary key, we non-nullable. The symbol and the element name will follow. Symbol should be unique, so it's not primary key, but should be unique also. And the element is the name of the element is long in char count, and also would be not nullable. Atomic mass, period, etc., etc. You can create the database structure via a script in MySQL using the SQL. So with this file, periodic table.csv, you have all the columns needed to create the database. You can ask the artificial intelligence to create the SQL file or script to define the schema of the table, and it results after loading the schema in something like this. We have made some changes that will be seen in the loading script, but you can see there are some booleans which are considered as tiny ints, as MySQL doesn't have boolean type, which will be 1 in case it's true, or a value different than 0 in case it's true, and 0 in case it's false. So if it's radioactive, it will be 1. There will be a 1 here. If it's a metal, there will be a 1 here. If it's not metal, also. If it's metalloid, there will be a 1, or in case it's not true, there will be a 0. The group type is a change to the group. So you have many groups in the periodic table. The first, the number 1, number 2, number 18, for example, for noble gases. And we have changed the name group on the column to group type, because group is a protected word in MySQL. Then we have added some units in atomic radius. For example, you have picometers, first ionization, electron volts, density in grams per centimeter, cubic centimeter, melting point in Kelvin degrees, boiling point in Kelvin degrees. So it provides more information, because the units are important in chemistry and physics. So then, to load the data after the structured database has been created, we can ask also Gemini to generate the script. In this case, or by default, it chooses Python, which is very powerful and effective. So I have no complaint to that, and use this file. You can see it on an editor. So if you want to understand what it does, you can see it uses the pandas library MySQL connector to connect to the database, identifying the user. You have here the configuration for the host, username you have chosen, user password is clear text. This is not very, I mean, in terms of security, it's a security breach. So just to do it locally is no problem. The database name, and then you provide the CSV file path. So this is where we have all the information stored for the periodic table of elements in this CSV file. The target columns we will read from this CSV file, and then we will build a insert into periodic table for the whole query. I mean, we will build and insert into predict table for each column. Here we join the target columns. So in one line, we will add one element. There are 118 elements in the periodic table. It will be 118 inserts. Here we create the connection to the database. In this define function, then this defined function reads from the CSV file and creates tuples to be inserted for each pair of uh, attribute value. We read when here is the execution of the main file. We try as if there is an exception to read from the CSV file using pandas. If there are no errors, we rename the columns to those most specific values with the units also, and drop the column natural, which is in place and is not used in the table. Then we ensure that the data frame matches the target column list. So the data frame is as it is on the target columns. Connect to the database using the configuration values and load the data. Then we close the connection to the database. Well, and at this time, we will have all the data information loaded in the table. You can check, for example, with an SQL query that all the data is in place. First, we will do a describe of the table. You see all the columns, the values, the restrictions. And if you want, for example, the list of the group 18, which is the noble gases group, you can do that in the following way. So, for example, atomic number, symbol, element, atomic mass, phase, type, group type, from the database, which is, you see the name, where group type equals 18. And you see all the noble gases: helium, neon, argon, krypton, xenon, radon, organexon, which must be non-stable, so it says artificial. In this case, means that the element is not stable in natural conditions, so it's only there in experimental phase and soon disappears. It is detected, it is possible for it to exist, but in the conditions on Earth, it is not supported, so it will disappear soon. The rest can be found in nature, but this one is artificial. This is not found in nature. Once we have this data loaded in the database, we can ask Gemini, on how to create this graphically in a periodic table of elements in which each element is a button. So if you click on an element, you can read all the database parameters from it. And then Gemini replies that this is a complex request that requires generating a full stack web application using HTML, JavaScript for the front end, and Python or Flask, and Python and Flask for the back end in order to interact with the local MySQL database. So it says you must have some requirements. Python install, obviously we have Python install, pip to install the Flask library, and the database should be already populated, which everything is in place. You install Flask and you can run the application. Then the look and feel will be something like this, and I will show you how to execute the app to check how the look and feel works in this example. There we have a directory which is currently which we are web periodic table. We have there two files, the index.html, which is the presentation, the front end with the JavaScript commands, and then we have the application in Python. If we run the application in Python, it directs you to the local host import 5000, so that you can see the periodic table, the interactive one. If I connect to this URL, we see. So it only has generated partially until the third row. It could have been more extensive, but it only generates until the third row. I don't know. Perhaps I think the artificial intelligence just want to do the job as simple as possible, and instead of providing the whole thing, just provide the idea, and if you want more, you need to do it by yourself. I don't know if insisting it more, it will provide the whole thing. But anyway, you can choose, for example, Beryllium, and it shows here below all the parameters: discoverer, first initiation, electron volts, is a metal, yes, it's a metal. Solid phase, es un estado sólido, lo encontramos en la naturaleza. De tipo alcalino, alkaline earth metal. The melting point is about electronegativity, density, grams per cubic centimeter, atomic radius in picometers, etc., etc. We can change to lanthanum. This one is found in nature. Let's check. It's a metal phase solid, so it's found in nature, I think. Actinium, aluminium, it's a metal in solid state. Well, and if you want to practice more, we will try to build more examples so you can see the applications of these artificial intelligence agents. Hope you have enjoyed this small chapter, and keep in touch. See you next chapter.